I'm hoping to talk a little bit about the sort of practicalities of MEC and how do you actually go about deploying an app, for instance, and then close off with something very close to that, which was the hackathon, actually the series of 3 hackathons that were recently held. So my name is Walter Featherstone, so I'm on the leadership team for ETSI MEC, technical manager for open source software, which I'll put there, but actually working for VRV. So first thing I want to look at are the steps to bring an application into service. So I guess we've seen some of this in the previous presentation with respect to more sort of orchestration, but this goes right from the beginning. So what we have, top left, is a device application. So this might be on, for instance, a UI.
Hey.
And the idea here is that the device wishes for a MEC app to be instantiated onto the MEC system as part of the host.
They're still coming. Okay.
So we can see in the middle of the diagram here the MEC app. So this is what the target point is. And the resulting MEC app would be called a user app. So it's a slightly different set. That's a way of distinguishing the fact that that's where the request originated from. So what the device app would do would request via the user application lifecycle management proxy over the MX2 interface that application was brought into service. So that's one option. The other option is it comes straight from the OSS, and this would be, the typical reason for this would be that there's a relationship between the OSS and so the operator and the platform provider would have a relationship where they wanted to onboard the application, and then this would be considered a standard MEC app. Oh, where do I point it? So I'm sort of going to go through the steps one by one. So first of all, the OSS is the point of origin for the request, so where the device application is making its request, or if it's come directly from the OSS itself. So the OSS will only onboard signed MEC apps. It will have certain controls over that app. So for instance, enable, disable, and delete controls, and query the app. And it can trigger instantiation of that app and enable application packages. So the next entity then down is what we term the MU, so the orchestrator, which is the MEC-specific orchestrator. So this assigns the ID for the package. So this is quite important because obviously we need to be able to uniquely identify which app we're referring to. So each app in the system will have this unique ID. It may prepare the Vim, so we saw that in Uwe's presentation about the steps to the Vim. And it'll select the appropriate location. So this obviously is a differentiator with respect to NFV. That it's very important where this app is actually going because we're talking about a specific platform at a specific location, and it'll have a specific service area. So it'll select the platform manager and also the host itself. And then it's responsible for the oversight of those applications. So next step is the platform manager itself. So that's over here. So it'll send the request to the Vim down at the bottom. So obviously it's important that when we establish a new application that we ensure that the appropriate resources are made available to it. So that's the compute and storage and what have you. And it will send the request to establish the application at the platform itself. So that will be the traffic rules, the DNS rules, and what have you, because when we're doing things like traffic steering, we need to know where to send it and which traffic should be steered. And it will also have visibility of, for a particular application, which services that application needs to run. So Alex highlighted some of those, the features, for instance, that the MEC platform itself may provide or potentially other applications provide. And it's important that when we're deploying an application, we know that those required services are available. Otherwise, the app, in all likelihood, is not going to run. There may be optional services as well, which potentially offer enhanced features, and those are identified accordingly. So next we go to the platform itself, slap bang in the middle. So this will actually configure the application instance. It will offer a number of assistance procedures. So it'll start the application up. It'll terminate it gracefully or abruptly, so stop or graceful termination. So if we want something to complete before the application is torn down, then obviously you've got that procedure is available to you. And then there are service assistance procedures it also supports. So this, what we see is here, that when we deploy a MEC app, it may actually offer services itself. So there are a number of service-specific activities that the platform will manage, because there may be dependencies on other services from the service that we're offering from this application. So if this application is offering services, and for instance we tore that application down, then it's important to notify, for instance, to other applications that are relying on that service is no longer available. And then finally, the service itself. So the app can discover services. So if a new service becomes available, it has the opportunity to discover that service is now there. And it'll be notified, like I mentioned before, that services are no longer available. The services themselves may be platform provided. So we define a number of features, as Alex highlighted, that the platform may provide, but those services equally could be provided by an application. And I've listed 3 of the features there: radio network information, location, and bandwidth management. But the interesting one, perhaps, is the third party provided. So the idea there is that a third party could come along and deploy a new service that applications could take advantage of. And that's why we've tried to develop this flexible framework with a specific set of rules and guidelines for developing such services and presenting APIs in a consistent manner. So the last one, and I've deliberately drawn the client over here out of the device app, but what it's trying to highlight is the fact that the client who's actually using the application may not be the same entity that requested its creation in the first place. So for instance, the device app could be used as a means to ensure the application is available, and then that application becomes advertised and the client is then able to use it. It may be that they're co-located, but it's just really highlighting that there's no expectation that they have to be. So the client will communicate with the MEC app in the middle using its standard means, so whether it's fixed line, WLAN, or cellular communication. And it will connect to that app using its standard means, so whether that's a URL or a fully qualified domain name. And as far as the client's concerned, it doesn't necessarily need to know where that application is. It obviously needs to know that it's available, and it will try and access it, and if it's not available, then I guess it will get the service not available type thing. But the key thing is it's transparent, the fact that it's deployed at the edge. It'll get the benefits of being at the edge, i.e. the low latency and what have you. But as far as the client's concerned, it's just accessing a service that it wants to use. And I guess an example of that would say, for a video service at a football stadium, well, it only really makes sense if you want to do instant replay and what have you for that service to be available at the, in the geographical bounds of that stadium. But the end user doesn't need to know that actually that service is being provided to them from the edge. And when they leave the stadium and go home, then that service is no longer available. And then just to highlight then that I've highlighted the filtering rules and the DNS handling. So it's just highlighting the fact that the MEC platform is what has ensured that the traffic is steered to the application appropriately. So now going a bit more into the detail on the services themselves and OpenAPI. So you've heard a lot about OpenAPI, and I guess that's probably been one of my main areas in the ISG. So we've seen this slide before, but the words are a little bit different on the right. So what we're really trying to highlight here is that we want to develop a great set of standards that are easy to use and fulfill the need that's out there. But what we want are for people to adopt those and utilize those, particularly the application development community. So we want them to use our APIs, and the way we've looked to do that is to present the APIs using these open API descriptions, which I'll show you and see how you can get access to those. But I wanted to just highlight some of the APIs first. So this is one of the features, the Radio Network Information API. And this just highlights some of the information that's exposed over that. So currently I would say that this is quite LTE 3GPP focused, but the expectation is that as 5G is developed and the information elements available there become more solid, then the hope would be to expose that type of information too. And I think a lot of the information here will be applicable to 5G, particularly in non-standalone mode. I guess as we go into standalone mode, we'll start to see newer aspects, and particularly with respect to the new radio and what have you. So just to highlight, the reason there are two trees there, there are the queries and notifications. So queries are very much, I want some information and I want it now, so I send a query to the service provider. Again, that could be the platform or it could be an application, and I want a particular piece of information back now. So things might be, what cells are associated with this MEC platform. So this would give me an idea of the geographical region covered by a MEC platform, or how large a geographical region is covered by the MEC platform. Now, if you wanted to be more specific, then you could use that information to then go and query the location API to find out where those access points are actually geographically located. And then on the right, we have notifications. This is more about, the actual mechanism is a pub-sub, so publish and subscribe. So you subscribe to receive notifications about an event that you're interested in. So an example here would be ERAB. So an ERAB is basically the connection between the UE and the core network. Or the gateway, rather. So for instance, you might want to know when such a connection has been established or modified or eventually terminated, because there may be more than one RAB between a user and the network. So if things change in that connection, you may want to know about that. So that's information you could subscribe to as an application. You could also ask for things like handover events. So when does the user move from one coverage area to another coverage area? So that could be useful when you're looking at things like application mobility. So the question was asked earlier about the mobility. So the idea there would be that why would you want to move an application from one MEC platform to another, or associated with one MEC platform to another? Well, handover could be one of the triggers potentially to initiate such procedures. And there's a number of other information elements. So you've got things like the measurement report, which talks about the RF conditions. So what channel conditions is the user actually experiencing at a particular point in time? So the last aspect to cover on this slide are these two, these two areas here. So in terms of maximum operability, what we want to make sure is that every API has a standard means to access information and a standard means of exposing that information. So every API will conform to the HTTP REST methods, or will define HTTP REST methods to gain access to that information, and it will be presented in JSON format. But particularly with respect to the Radio Network Information API, some of this information you're querying may come back very frequently. So if we look at timing advance, for instance, that could be a typical example where the timing advance between the network and the user is changing pretty regularly. And maybe you don't want to send a notification every time the timing advance changes. A message bus type approach using something like gRPC might be more appropriate in that instance. And therefore, through the API framework, and this includes MP1 too, there's the means to negotiate or offer access to this sort of information using alternative transports, as we've termed them in the ISG. So, for instance, streaming. And so I've got the WLAN API as well here, and we'll see on the right-hand side that I've got those same bullets that they offer that maximum interoperability and the high volume options. So this was really to highlight that we're not 3GPP focused, so we do provide the same sort of information for a WLAN. And as Alex highlighted, there's another API relating to fixed access, non-wireless, I should say. Again, you have notification inquiries, and I've sort of deliberately switched them round as compared to the last slide, because there's this interesting aspect here with respect to queries, where through MEC 9, the API principles, and you'll see something very similar in NFV too, we've investigated a means to select specifically which attributes you want to receive information about, and this became, this sort of issue came to a head with WLAN because there's so many attributes that are available with respect to, say, an access point or the station, i.e. the end user, and we wanted a means to allow you to query for only a specific part of that information. So a new attribute selector with filtering, so you can explicitly query for the attributes you want, and then even filter those attributes to reduce the amount of information received. And a consequence of that is the resource tree is a lot simpler. So we don't have, if we had every attribute, you'd find a resource tree that looked like a tree with a lot of split branches. So by going for this approach, we've allowed a lot more simple resource structure. So the information on this slide was presented before, but what I wanted to highlight is OpenAPI is not an ETSI initiative. This is a completely independent initiative to provide an open source way of defining and creating RESTful-based APIs. So you saw that for every API we provide a RESTful access. And what's nice about that is it inherently includes the data structures. So what you'll see is all the attributes that we define in our specifications are available in that OpenAPI description. So you can see all the information elements, you get the description of what those information elements are, and you actually get an example of a valid value for each of those attributes. So you sort of get a pretty good idea of what sort of information you'd expect to receive and what exact format that would be in. And this file is also machine readable, and what's great about that is you can use third-party tooling to take that description then and automatically create a client or server stub, and I'll show you those, which means you can basically establish the appropriate communication path and know if you use that communication path you will be compliant to the ETSI MEC specs. It will be interesting if we get on the NFV route and do the plug testing to really look at whether or not everyone implements them in the same way, but the hope is that we've provided this means that ought to be possible. So in terms of why we've done it in the ISG, we wanted to validate our specs, make sure what we were writing made sense, we could actually translate that into the OpenAPI description file, and actually make sure that the information we thought was being transferred aligned to the specifications. But perhaps more importantly was this idea of accessibility and feedback. So this outreach to the third-party developers and encouraging them to use our APIs and then provide us with feedback to say, are they doing what we'd expect? Are there things missing? What other features could we potentially develop? So this is Forge. We saw a smaller picture of this, but basically if you go onto that site, you will see this page. It's not locked down or anything. It is in the public domain. And you can see that those APIs, those service APIs are already there, and including the platform enablement so that interface between the app and the MEC platform is all available. I think Alex has covered a lot of this in terms of what we want to do with it. So move to the latest version of OpenAPI 3. The motivation there really is OpenAPI 3 just supports some nice features, for instance, links, so moving more towards that sort of hypermedia component of Hatos, I guess, rather than HTTP. And also provides things like callbacks. So OpenAPI 2 doesn't very well support the pub/sub mechanism. You can sort of do it, but it's not very elegant. With OpenAPI 3, you get a much more elegant way of presenting the callbacks, this idea of sending a request for a particular set of information, and then what the notification actually looks like. And this one's probably perhaps a little bit more contentious, but I mentioned that using the OpenAPI description, you can create that server and client stub. But I guess what's really interesting is the platform itself, so actually having platform functionality. So you can actually develop an application and have this reference architecture or implementation that you could test your application against. So we'll see if that happens. But and then this is the actual meat of it, where we actually go into each of the APIs. This is where you'd actually go and download a specific spec, for instance. And then here I've taken the radio network information API. So we can see we have a JSON and a YAML description. The proto here, I haven't put a bullet for that, but I probably should highlight it because it's the Google or the gRPC, the streaming component. So we've even provided an example for what that might look like if someone were to implement the alternative transports. And these are the ones that I'd actually suggest people went to, because I guess even reading the YAML it is pretty human readable, I would say, but perhaps not so digestible. These two options are really the interesting ones for exploring the APIs. One, we can open this Swagger UI, and I'll show that in the next slide. And the next is the API inline, where we actually can go and edit the description and make changes and see what happens. So this is what it looks like. So that's the Swagger UI. So we see all the HTTP methods and the resource tree. This is the editor. So that's actually the raw YAML. And here what I'm highlighting is that when you use this third-party tool, you get the option to generate the server, you get the option to generate the client. Here I've just selected Node.js, and you can hit that and it'll just download. And in fact, here's the example. So all I've done is download that, stuck it in this directory, and then you just use this npm start. And in doing so, it'll just fire up the server stub. And you can access it on your local machine, because that's where it'll run, unless you've pointed it somewhere off your machine. And showing that you can actually then open that on your own browser, on your own machine, and play around with these methods. And then from a client perspective, you could use the same method to generate a client, but a simple approach would just be to use curl, for instance, and just curl the server. Here that's the local host again. There you see it's the radio network information. Version 1 of the API, we want to do a query. We want PLM info, and you have to specify an app instance. So we've fired off the query, and then this is the response. So you can sort of see straight away that you actually really do get what you'd expect to see. I'll jump over this, but it's just to highlight the fact that it links directly to what you'd see in the spec. The slides will be available. We're not protective of them. There's the wiki, which has more information, so tutorials about creating the files and how to interpret them. I'm just conscious of time. It implies I've got more time than I thought relative to the absolute time.
That's okay. I saw the NFP guys run over by 2 minutes. So.
Okay. This tells me I've got 5.5 minutes left, but then I realize I'm close to the hour. So this is just to highlight that if you want to contribute, You can just use your ETSI account, or there is another option if you're someone not a member of ETSI, or obviously, hopefully you all are. But it just highlights that it really is an open platform. And then every spec, so this is the annex that you'll find in every GS, and it just tells you where to find. So if you're not quite sure where to find the Open API description, in every spec there is that direct link. So if you take the Word or PDF version of the spec, you will be able to find the Open API description if the forged link isn't obvious. Quick one on linking the versioning. So it says what version of Swagger you're using, or Open API, version of the spec, link to the spec, and then version of the API. And this is why I was rushing, because I wanted to talk about the hackathons, because this was a big event. And why we did it, we really wanted to promote the work we'd done, and we want to actually provide a means for those third-party developers to come and have a go with our specifications. So it's all good and well even doing the Open API, but people still have to use it. So the next step was really to start up these hackathons and actually get those third-party developers to come along and play with our APIs, and give them a bit of encouragement with respect to prizes and what have you, to try and build that ecosystem. And it's very good to hear from Alex that in order of 15 teams were represented across the 3 hackathons that were held, which is I think pretty good, given this is the first time that we attempted this. And the idea is to glean feedback from what we've done and look for areas, new use cases that we can address, and potential any issues with the APIs and new APIs that we could develop, and new services. So it's really trying to foster that innovation. So you've seen this slide. This just gives an example, again, going into that Open API description and how you can use it. There were the 3 events that were held. And each of those links is still live, so you can find out a lot of information on the hackathons. And then just to highlight the winner at the ETSI, the official ETSI hackathon, which was in Berlin, so it's EdgeGap. So what I really liked about this entry was the fact that someone had actually taken our APIs and developed a real service. So basically what they were doing, they were using the ETSI MEC APIs to find out where the players of a game were located, and then deploying the application at the most optimum location based on where those players actually were. So they're using the location API to do that. And what I also liked was the fact they deployed that same application on 2 different platforms from 2 different vendors. And those vendors also offer different ways to deploy apps, so one in VM and one in containers. So it was showing that what we have already is very portable. So I think I'll jump to the thank you, and I've cunningly put Alex's contact details on there rather than my own, but you're more than welcome to contact me too. So I think all my details are in the program and what have you.
All right. Thank you very much, Walter.
You're welcome.